Mm, Morning. I think I just stopped sharing my screen. There you go. Back again. Morning, Christopher. Is my sound coming through okay? Doo, doo, doo. We got several of you. Good. Okay. Great. Who have we got on at the moment? Got a few of you. Cody, Derek, Leo, Matt, Kristen. Good. Christopher. All right. So let's sort of get going. Um, Before I get going, quick question. Um, I'm going to be sending out a survey as soon as I get it finished by hopefully over the weekend, trying to get feedback on so I can help plan the course for next winter. Uh, and Since we're all online now, did the university send out any notice about course evaluations? They haven't told me anything, or at least I haven't seen any notice. Have you been asked to review classes yet? Yeah, okay, it's in Brightspace. All right, thank you. That um, just as long as you get an opportunity to give me some feedback. It's often very slow, but now that they're doing it online, maybe it'll be a little faster. Last year's course evaluations for the fall, I got in the summer. It was in, actually, no, it wasn't in the summer. It was in September. Not very helpful to me. Anyway, okay. So today, like I did with my class yesterday, I'm going to start out, we're going to focus on assignment 5 and walk through a variety of things there on it. Pretty much did the assignment for them, but so what? Um, and that ended up taking up about an hour. And so I raced through the slides I've got for today very quickly. I'm not sure how critical it is at this juncture because the last things you've got, the big point thing is your assignment for tomorrow. That's 10 points. And then the quiz on Saturday if you need it, because we're picking the best 10 out of 12. Um, that that's only worth 2 points. So anyways, this assignment's a big deal, so let's focus on it. And once again, a reminder, because I keep getting emails and questions, there is no final exam. On Saturday, you are finished. So let's look at the assignment. Unless you've got other things you want me to talk about first. Yes, I'm way behind in my grading, so your marks are not up to date at all, especially assignment 4. Um, and I'll be working on that stuff, and hopefully I'll get caught up. And my tentative plan is to get grades finished by around the 15th of December, thereabouts. And so that there's lots of opportunity to give you feedback, I had hoped, in between, and you can correct any mistakes I've made, and we can get stuff sorted. But anyway, so um, your assignments, again, a drug testing, medical testing type question. Um, I, it seems repetitive, and you may wonder why is it that you should care about these. This one here actually is a business application. The numbers are made up, but it's based upon a story out of the U.S. to do with uh, truckers not so much using, uh, uh, you know, hallucinogenic drugs or alcohol or that sort of thing. It's drugs to keep them awake so that they can drive longer. And this was a few years back. And there was real concern about it because they're at risk of causing accidents. Um, and it is somewhat dangerous. And firms were afraid of their liability. And so they started setting up different types of testing programs and concerns about how accurate the testing programs are. So I made up that was the context. So, but these numbers are just made up. Uh, should you care? Um, well, give you an example that was on the radio. Is it yesterday morning? Yeah, I think it was yesterday morning on The Current on CBC. They were interviewing a couple of senior people at couple of universities in Canada about cheating on exams uh, in in this online COVID world. And one of the things that came up was, cheating always goes on. Come on, it's not new. It existed definitely in my day, long before technology. We had all kinds of ways to cheat, and many people unfortunately did. And I don't know if it's any more prevalent today than it was back then. It's an issue of not. Uh, it's under what stress people are, and does the opportunity arise, and then there's some that are, I'd view as the criminal element, that consciously plan to cheat, and whatever you put up in their way, they're going to find a way around it. They're crooks. But that's a very, very, very small number of students. Most of them that do cheat, it's because they were under stress and they panicked and the opportunity arose and they took it. That's not the end of the world. Anyway, they were talking about using technology and artificial intelligence. Now that relates to this course. And so there is some software out there that will video you while you're taking your exam. So you've got to have a little webcam here, like I've got in front of me, and that it monitors your behavior. So it isn't just a video is taken and someone's going to watch it. It's that actually there's software behind that tries to monitor your body movements and what you're doing, and from that detect suspicious behavior, and then it comes up with alerts that suggest you may be cheating. And if enough alerts come up, then there's the accusation that you're cheating. But if you're a very nervous person or you have a twitch or something like that, start picking that up. If you got ADHD and you keep having to look away and you do that sort of thing, it's going to think you're cheating. There are all kinds of different natural things that we do that are misdiagnosed. Um, and so there's real concern. It didn't seem to be a big deal with these people being interviewed, but I would be very concerned about the number of false positives, the number of students accused of cheating when they aren't, because it's really difficult for the student to prove that they didn't. And the professor is just relying on a computer program that says they are. And how do we trust that? Anyway, so we'll go through here and do that type of thing. But I must say that the use of technology in the workplace is going to increase. And this type of monitoring of behavior, that's going to happen more often by monitoring all kinds of stuff that within Top Hat, I can't monitor an awful lot in Brightspace. I could look at, see what you had looked at, when was the last time you viewed a document. There's a whole bunch of data that's being collected upon you as you use Brightspace. And the same with any other software program. There's tons of background data being collected on you, and people are analyzing it and trying to make guesses about things from that. Um, and that's not just in teaching. That's going to happen in the workplace with software that employees are using. Scary. Anyway, Big Brother is here. So in this one, we've got a situation. It's similar to what we've had before, but there are two stages of testing. So what they do is they administer a urine test to the truckers before they head out, or maybe it's once a week or something like that. There's some testing regime. They can get the results back very quickly, and it's a very quick, simple test. It's very inexpensive. Trouble is, it makes mistakes. It misses some of the people that are using drugs, and on the other hand, it identifies positive results for some people that are not using drugs. And this is common with various types of tests, that other things can trigger things one way or another or mask it one way or another. So, but if you get a negative test, they say, fine, we won't worry about it. And if we missed a case, we'll test them again later and we'll catch them eventually. But if it comes up with a positive test, to make sure, because these false positives, that we don't want to accuse someone that's innocent, we're going to administer a blood test that's more accurate, more expensive, takes a lot longer to get test results back. But this way we can filter out, and if you fail both tests, then you're in trouble. So that's the context. What the company doesn't know is what percentage of its drivers use drugs. And that's generally the case. In any of these testing regimes, we don't know what percentage of the population has COVID and how prevalent it really is. In Olympic sports, we don't know what percentage are actually using banned steroids and that type of thing. All of these ones are fairly common. So we do it basically as a what if. We make an assumption about how frequent it is and then see under that assumption what types of results would we see. And so that's what you've got. This is a sequential problem. First, someone has to use the drugs or don't. Then we do a urine test. Then we do a blood test if we have to. So it goes in a sequence. And when it goes in a sequence, and there's no going backwards, it's always going forwards, then a tree is a very useful tool to visually organize the information that uh, you may be able to picture it. But when you start putting in the probabilities and try to figure out how to do your calculations, you got to think very carefully. And it's easy to make little mistakes. So organizing it in a tree and working through the tree helps you see what you're doing, and it helps reduce the number of mistakes you make. And and all kinds of things. We try to devise tools to try to prevent the way mistakes we make. It's like a plug has a fat end and a skinny end, so that you always put the plug in the right way. That it forces you not to make the mistake. So um, first thing is the tree, and because it's so important, I'm going to build you a tree. Let me just get as much workspace as I can. There we go. Okay, so I've got a good clean sheet. I'm going to build it in Word. You don't have to. It's really awkward to do in Word. That what you can do is just hand draw, take a picture, and paste the picture into your assignment. I'm going to do it by drawing stuff. And um, someone told me that if I use smart art, I could do this faster. I don't know. I don't know how to use it. I'm really, um, I do things with the basics. I'm going to just use simple drawing tools. Okay. So at the very beginning, we have two options. You either use drugs or you don't use drugs. That's your starting point. So you've always got to figure out what is the thing that comes first. Make sure you get that right. If you don't, everything is messed up. So I could use drugs. There's a line for that. I'm going to make my lines fat so I can see them. Okay. And instead of going up to draw it every time, I'm going to copy and create new lines as I go this way. Okay. And I got to label what's happening with these. Let me just tip this guy out a little bit more, give myself, oops, wrong thing. Okay. And along this branch, I'm going to put the top being using drugs, the bottom being not using drugs. So yes is up and no is always down for me. So I'll put a little box in here. And um, so drugs. So if you're going to give it a label, just D for drugs, then separately, you should have a statement saying D equals uses drugs. That every time you use a symbol for a variable, that when you label a variable in some fashion, it's just the same as within having a data dictionary. You've got to have labels to explain what they are so that people know D is. I know it's sort of obvious, but uh, it's really bad people that use X and Y because nobody ever knows what X and Y are. So D is going to be drugs. And then I'll need another box. I'll put it down here. And I'm going to actually call mine not D. I could have used D with a little tick mark up here instead um, to be the complement. Uh, I don't need extra symbols that I don't really need. And it's clear to me that it says not D. Um, I put it in language that you can remember what it is. Don't fuss so much with these different notation conventions. It's got to communicate to you effectively, because if you have to, you don't want to misinterpret it by mistake. Sometimes hard to see the little mark up there. So we can go up this branch, go down that branch. In labeling it, we should always label what percentage of individuals go up one branch or go down a different one. And in this one, we're told that 6% use drugs. So just put a 6% in there. That's my suggestion. And so that would mean you have to go to one way or the other. You have no choice. You have to go somewhere. So this has to be 94%. That you could, if you wanted to, oops, this isn't working. Let me just put it in this space up here at the top of my screen. That at 6%, it's like having written in probability drugs equals 0.06. And some people might ask you to do it in a more formal fashion like that. For me, it's enough to see that you're saying 6% go up and 94% go down. And then I'll show you something different in a minute. And then once we're here, what happens next? Well, that once I get to this stage, I'm going to have a urine test. And a urine test is either a positive result or a negative result. So there's two options here. And in addition, that whether I use drugs or don't use drugs, everybody gets a urine test. So this is going to have to apply down here as well. Excuse me, I don't want to lose this. It said drawing in Excel is a pain, or Word is a pain. In Excel, it's just as bad. And grab one of these guys. So here are my different cases that I've got. And again, I should put a box in here to describe them. So I'll put in a little text box. And up here, these are, since I'm putting positive things on the top, yes on the top and no on the bottom, I'll put U and a plus sign, mean a positive urine test. And again, up above, I should put U plus equals positive urine test. Okay? And that can also happen whether I use drugs or I don't use drugs. I can get a positive urine test. Just it's more often up here than it is down here. The other thing that can happen is if I can get a um, um, uh, a negative test. I should put that one in here. And whoops, what do I want to do? Yep. Hey. As I said, it's a real pain doing these. There it goes. Never quite does it the way I want it. The information we're given about these tests is up here. So with the urine test, what does it say? It says 4% of the time when using drug, it does not indicate the presence. Okay. Let me highlight that. So that is you're using drugs, but it doesn't show up. This happens 4% of the time. So this must be 86% of the time. And then the other thing tells me is that 2% of the time when it's not using drug, the urine, yeah, see, so you've got errors both ways. So I have this problem down here. When you're not using drugs, 2% of the time it says you are. So I guess 98% of the time it comes back and says, no, you're not using drugs. Are you comfortable with that? Anybody have issues at all? No? Okay. Then let's take it a bit further. If you get a positive urine test, you're going to have to take the blood test. And, whoops. So now I've only put in these ones here. I haven't put in these guys. Any branches off there? Any reason why? Cody's typing. Okay, smart art works well. I'll have to look into that later today. This is just so tedious. that any thoughts on why I've only put in these 4 branches here and not put branches on the other guys? Mm, some people are typing. Yeah, basically right. Yeah, you're only supposed to do a blood test if your urine test is positive. If you get a negative on the first time round, they're saying fine. And it's the same way if you were at, where was it? At the Sportsplex, I think, yesterday. They were doing the rapid tests. If you get a negative rapid COVID test, they say it doesn't look like you have COVID right now. Um, can't guarantee that, but you can go home. But if you get a positive test, they're saying, okay, we need to do the other swab and do the big test. And we had asked that you quarantine yourself until you get test results back. So only on the positive ones are they doing the second test. And so let's go and add some squares in for this case. Um, and so this is a blood test and not 96%. Let's just go and that one, and then I'll make it negative. Whoops. And oh, wrong there. It's going to give me grief. Yeah. Okay. So what are our numbers for this one? So it says the blood test. This is about missing people. It happens 1% of the time. And with people not using drugs, it's 0.8% of the time. Okay. So this happens, what did I say? 2%? 2% and 0.8%. So this is missing people again, is 2% of the time. Oh, shoot. come back here. And this is 98%. And down here, this is 0.8%. Don't like percentages that go below 1. This would be 99.2%. Fooled by decimal points on these ones. And so this summarizes all of the different things that are going to happen. And it's useful, but actually, if we were looking at calculating probabilities and that sort of thing, we need to combine all these sorts of things together. And it's done by multiplying them, thinking through why do you do that and what formula do you have. I could write out the formula for each of these things, but that one, like I've said before, I prefer doing by making up numbers. And I'm going to start out at the very beginning, whoops, with a whole bunch of people. Suppose I start out with, and this is a crazy number to use, we're not going to apply this test to 1 million truckers, but let me start out with 1 million truckers. Okay, and see what would you see happen as you go through. So if you've got 1 million truckers, how many are using drugs? Anyone want to give me a number? How many do you think are using drugs? Yeah, 60,000. I have to be careful. When I first did this, I accidentally typed 6,000. Didn't notice my mistake as I went along until at the end. But you have to be careful that with all these zeros that you've got. And it's the same way if it's keeping track of all the zeros, it's also keeping track with decimals if you're using probabilities. That means down here I've got all the other people. That's 940,000. Let me just, there we go. So there are all the people that aren't using drugs. And then of these 60,000, I'm going to split them again. Um, uh, for me in my head, the easiest thing for me to do is take 4% of 60. 4% of 60 is going to be 2,400. That, and so that would leave up here 57,600. Okay, so that's how that group has been split up. And then down with this group here, if I take 2% of 940,000, again, it's best probably to use a calculator. Say I grew up in a generation where we didn't have anything like a calculator. We had slide rules. um, and you can't do things exactly with a slide rule. That the So there was a big emphasis on mental arithmetic. So I do try to do everything in my head, but then I still make mistakes. And then this one I've made mistakes too many times on, but I can remember what it was. There we go. It'll be 921,200. You can go back and check yourself on this. I started with 1 million, 60 plus 940. I've still got 1 million. Here I got 60,000, 57,600 plus 2,400. That adds up to 60,000. Good. 18,800 plus 921,200. Add them up. I get 940,000. With you, I'd suggest you actually multiply the percentages and then check to see if you did the arithmetic correctly, rather than doing the subtraction that I'm doing in my head at the moment. When I get out here, it's just this is too early in the day to do in my head, so I might start with the 0.02, 2% times 57600. Doesn't look right. All right? Was that supposed to be 2%? Let me just check the assignment. I think the way I did it yesterday, I used 1%. Oh, see, it is 1%. There, see, I did make a mistake. This is supposed to be 1, and this is supposed to be 99. So I can do this one in my head. 1% is 576 people. And this then must be, ooh, uh, brain's asleep now. That's 57,024. Oh, yeah, that's right. Yeah. Okay. And down here, definitely need a calculator. Point, oops, I do here. Times 18,800. Oops. Is that right? 18,649.6. So I didn't get rid of all my decimals. To make it a huge thing when I tried pasting it in. Oh, good. Okay. Oops. And this one is 150.4. This one here I've made mistakes on a few times. I've accidentally typed in 0.08 and 0.0008, so on different occasions. So one time I got 15 people, and another time I got 1,504 people. Said it's easy to make mistakes, but if you do the multiplication, then you do your self-check. Add these two together, and you should get 18,800. If I add up all the ending numbers, the 921,200 plus the 150 plus the 18 plus the 2,400, the 576, and the 57,000, I should get 1,000,000. Okay. Should you keep the decimals? For these guys, they're not that important. You can round because there's so many digits here. I wouldn't fuss. That's if you're expanding it out the way I did. That with this tree, all I asked you for is to just build the tree and label it. So you didn't have to do these calculations, but you're going to need them to do question 2. So you're going to have to do them sooner or later. And then there is an issue, and we'll see in terms of what I've asked you to do in question 2. Where's question 2? Okay. So I was nice enough to give you a table, fill in. And the table, if you look at it, so as I said, this just describes all the outcomes, and you can get a sense of thinking, I had 60,000 drug users. Here's 57,000 that I caught. That's good. Here's 576 that I wrongly accused. Or no, sorry, that I missed. They were drug users, and I missed them here. And I also missed these 2,400. They got away because they got a negative test. What about these people that aren't drug users? Well, initially, I had, what did I do here? Nobody's caught my error. Yeah. Silly rabbit. I don't know if you spotted it. Uh, this was only 0.8% were supposed to come out positive. Yes, 99.2% are supposed to be negative. So almost all of these were supposed to come out negative. Whoops. So this actually should be 18,000. What is it? 649. Down here, wrong place. These are people that didn't use drugs. Initially, I accused almost 19,000 of them of using drugs. That's a lot. But after the blood test, it's down to only 150 that I'm falsely accusing of using drugs because they got two positive tests. Um, all the others, I've made the correct decision on. I've said, no, you're not using it. Before I go forward, have I made any other mistakes in this? No? Okay. Oh, Derek. Okay. Um, but it's, you've seen me making mistakes. I'm talking and trying to do this stuff at the same time, but it's just so easy to do. You just get things backwards by mistake. And this is the third time I've done it for you, as well as making up the solution key and so on. So I've done this a few times. I should have it right by now. Oh, so the table is nice because you'll notice there's, excluding the totals, there's only 6 boxes here. And notice what they are. On the left, it says negative urine test, and so it uses and doesn't use drugs. Here's the negative urine test for uses drugs, doesn't use drugs. And then these other ones, I've got positive urine and positive blood test. Here's the positive urine and blood if you use drugs. Here's the positive urine and blood if you don't use drugs. And the other one is the positive urine and the negative blood. So the last ones. So there are, at the ends of my branches, there are 6 endpoints that I've got. And I'm asking you to just summarize them here. But I asked you to give me probabilities. My tree doesn't have probabilities in them. Let's just put the numbers that we've got in here. So uses drug, negative urine, 400. Put that in there. And does not use drug, and I get a negative urine. Oh, that's this one down here. Oops. I got positive and uses drugs. That's this one. And positive and doesn't. I remember that one. That's the 150.4. And I've got positive urine, negative blood, uses drugs. That's the 576. Remember that one. And this one is this big number, I think. Now I check my math again. Add these numbers up, and you should get, where are we? 60,000. Because 60,000 out of a million use drugs. And I should get 940,000. So these totals for me, there are a number of them that the answers I know, and I can use them to double check my calculations. Because again, as I said, it's so easy to make mistakes. These ones I'm going to add across. And so when I add this, I'm going to get 923,600, I think. And here I'm going to get 57,174.6. And here I get 19,000. No, I don't trust myself. What am I at? 18,649. 18,649 point. Sorry, this is 0.6. I got a typo up above. Plus, what was it? 576. 19,225.6. Yeah, that's thanks, Jeff. I spotted the same thing when I was doing it. There's something wrong here because one of them ends in 0.4, one ends in 0.6. And if I add them all up, I get 1,000,000. You're not asked for this. You're asked for probabilities. So with probabilities, that what you have to do is change it to a decimal, divide by 1,000,000. So dividing by 1,000,000 is moving your decimal point over 6 places. So move it 6 places. 1, 2, 3, 4, and 5, 6. What this is a decimal. This one, I need to put a 0 in there. There it is. This one, and a decimal. That one's already got 6. This one's tricky. Okay, it's moving the decimal point. So take it away from here. 1, 2, 3. And this one, just take it out. What did I do here? Made a mistake up there. Need one more 0. And here, whoops. I need to click. Oh, my column doesn't add up right? Oh dear, I'm in trouble then. I'll have to go back and check that then. And just take that guy out. So the total column doesn't add this way to being 1,000,000. So I got 923 plus 57 is going to give me, so that's around 980. And this would be 19, so 99. So does this not add up to 600 plus 175 plus 225? I think that adds up to 1,000. It should. I think I got it. Double check. We can check on that. So I've got 923, 600 plus 57, 174.4 plus 19, oops, 19,225.6. I got it. Works. Okay. But it's easy to get it screwed up. Yeah, we all do. We all make mistakes. You see me, I'm making lots of them. So to change frequencies to probabilities, by doing it with the total being a nice round number, like 1,000 or 10,000, 100,000, 1,000,000, to change it all, it's just moving the decimal point. And I get all the things I had before. In this fashion, I must say, looking at this table, I'm having trouble reading it right now. It looked confusing to me. because I can't picture decimals. I have trouble trying to picture 0.000576 or 0.000150 What is that? But when it was 150 people or 576 people, I could see that. Um, that, uh, and I don't think I'm that different from an awful lot of other people. And I work with numbers all the time, and I have trouble with this. Um, so that's where you're going to in the second one. After you've got that, and I'd keep the frequencies, even though the assignment calls for the probability table, I would also keep the frequency table because the frequencies I find easier to work with to do all the other questions that are there because I recognize what the frequencies are. I'm very comfortable with them. So, what's the chance of getting a positive urine test? That's a positive urine test. That's a positive urine test. So, probability urine test being positive is 0.057, blah, 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 blah. Whoops, put an equal sign in here. Plus 0.019, blah, 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 blah. It's going to end up being something like 0.76. And there's more decimals. Uh, so back to the question that I can't remember who asked earlier, how many decimals to show? With this one here, I generally show my answers to having two significant digits. So I've got two now. I've got a sorry, yeah, I already made a typo. I've got, ignoring the zeros at the lead, I've got the 7.6. I'd say, oh, this means 7.6% chance of positive urine. Okay? And I know there are more decimals, but it doesn't matter. As it is, um, whether the answer was 7% or 8%, it's about the same to me and to most of us. We can't distinguish those fine levels. If you asked, what's the probability the driver is not using drugs if the urine test is positive? So this is positive probability, not drugs, okay? But we're given information. So that's if the urine test is positive. Now, if I was using frequencies, and this, because I don't need all this stuff about the blood test, I might just go up here. How many people get a positive urine test? Oh, 57,600 plus 18,800. And then how many of them are not using drugs? 18,800. Okay, I can figure this out. 18,800 of the people not using drugs got a positive test out of all of the positive tests. I can also get it out of this probability table, but I found just looking up to the tree is easier for me. There's a bit too much information here at the moment. And if I do this, I think it's something around 0.25. This adds up to 76.4. Okay. 18,800 divided by 76,400. 0.246. There we go. Well, I might just say it's a. That makes sense. Pretty high. A quarter of the people with a positive urine test are not using drugs at all. Three-quarters of them are, okay, but we'd be making false accusations against a quarter of those people that had the positive test result. So it's not that sensitive a test at this stage, just using the urine test. You okay with that? Has anybody got any issues with it? No? No one's typing? Okay. Then you could go to the next stage and say, I want the probability, not drugs, that if, so this is conditional, I'm looking at a subgroup, I've got a positive urine test and positive blood test. So look at those. Who has a positive urine test and a positive blood test? Oh, I'm using frequencies. Of those not using drugs, at least in my tree, that's what I'm using. I'm using the 150.4 people out of the 57,174.4. So that's a pretty small number. Seven thousand one seven four four. Whoops. 0026. Okay. So it's a 0.26% chance. That's like 1 in 250. So up here it was 1 in 4. Now it's down to 1 in 250. So it's um, a pretty small chance that you're going to be uh, using drugs with that sort of problem. That um, we're not going to make nearly as many false accusations. We're still going to make false accusations to a certain number of people, certain number of drivers, unfairly, but it's far better than what we were up here. Using two tests is a lot more accurate than using just the one. Not surprising. Any questions on this stuff, on how to calculate probabilities? But if you were to try to think about getting these answers, I think generally, I know we've done a lot of work building a tree, building a table, but um, I can answer all kinds of things once I've got a table. Uh, and I don't need to remember a whole bunch of probability formulas. We've used a bunch of probability formulas. We've used Bayes' rule in here, a complicated version of Bayes' rule in the background, because we flip things around in both of these. But we haven't had to think in terms of those. We've just tried to reason it out, hopefully using somewhat common sense. The next set of questions are based upon taking this table and rearranging it again. Okay? That these are outcomes of testing. They are not decisions. Sometimes they're both the same. You predict this, and so you decide that, and they both fit. This one is a little bit more general than that. If under what conditions would I accuse someone of using drugs? The table I'm going to have here is my confusion matrix. This is the truth. Either the truck driver uses drugs or doesn't use drugs, and we make a decision. Hey, you're using drugs, or no, don't think you are. Okay. Under what conditions do we say someone is using drugs? You guys still out there? When? Okay, Christopher. Uh, when the blood is positive, um, in my table here, so I've got to get to that. positive blood only happens when I've also got a positive urine. So this row here, if you're in this row, then I'm going to go and say you're using drugs. But if you're in the other two rows, you're not. All right? So what I've asked you to do is summarize it as if we've got 10,000 people here. And so in the 10,000, we're going to have 600 drug users and 9,400 that are not, because this is the truth. So the columns, again, describe the truth. And so up here, we're going to have uses drugs, uses drugs. So that is positive, positive. That's 570.24 people. And the other ones, essentially the other 30 people, if you add this guy and this one, you're going to get 0.002976. So this is 29.76 people, about 30 people. And over here, I've got these 0.00015. So if I have 10,000, that's 10, 100,000. That's 1.5 people. Okay. And so I guess I've only got 9,398.496 people here. Is that right? Yeah, I think so. And if I add them across here, I've got, I should know this from up above, 57177. 571.174. Is that the right number? No. So what's this number? 9,428. 0.256, I think. I'm clear by it, but I think those are the right numbers. So you can round these off if you want. Makes it easier. And this would describe the outcomes of our various decisions. What's an accuracy rate? How often am I making the right decision, or which cases am I making the right decision? That's what accuracy is how often are you right? If this was a true-false test and the correct answer was true or the correct answer was false and you picked true and false, what would be your grade on this test? There are 10,000 questions on it. How would you find it? Nobody wants to take a stab? Mm, yeah, those ones are correct. Yeah, but it's more than that. Those are right. Also, these are right. These are right. And these guys are right. We have two ways of making a right answer. And these ones are, this is a pretty big number. And you're going to end up with something really, really big. It's going to be like 0.9968 or 69, I think. That's 99.7% of the time. That's your accuracy rate. Oh, sorry, not. Yes, you're right. It should be. Oh, I'm. Ah. So you're right, Chantonay. Does that make sense in terms of accuracy rate? You have a whole bunch of other rates that you've got here. Sensitivity rate. That sensitivity rate is going to be what percentage of drug users you catch. That's what sensitivity is of the thing you're really looking for. What percentage of them are you able to find? And so I found 570 out of 600. That would be my sensitivity rate. So of those correct decisions, I'm looking just at the use of drugs. The specificity rate is the correct decisions about those not using drugs. So of those not using drugs, what percentage do I correctly identify? Okay. So the first two rates that are frequently cited have to do with making correct decisions. And so they look this way. The second two rates have to do with mistakes you're making. So among those, so we've got the false omission rate. Okay? That what's the percentage of those um, um, were flagged as not using really are using drugs? You look up at your table, how many did you miss? So you missed 30 drug users. Among this group of 9,428 drivers, hidden in them are 30 that we missed that really shouldn't have been in there. These ones are drug users. So you omitted them. That's why it's called the false omission rate. And then we have a false detection rate, which is you accused 572 drivers of using drugs, but they all weren't using drugs. We falsely accused. So you can think of this as the false accusation rate. We falsely accused 1.5 drivers of using drugs out of that group. Um, and so I want you to write up some type of explanation in words like I've used. I've tried to explain what these rates are in this particular context about who the people are and what I've accused them of or not accused them of, or correctly or incorrectly. Uh, and then in 12 and 13, I'm just saying take two perspectives. Like we've got all these rates. Which one should you focus on? And it may be different people will focus on different rates. Maybe you get into a debate on the same problem because people are looking at different measures. They have different objectives. The firm has one set of objectives. The truckers or their union may have a different set of objectives. And so one group may end up saying, hey, this model is working really, really well in meeting their objectives. And the other one is saying, yeah, but we're taking the brunt of it. It's not doing well for our members. Or maybe it's the other way around, or maybe this test satisfies both. If I just use the urine test, I know I would have truckers very upset. If I'm using both of them, have we sort of, are both groups now reasonably satisfied with the outcome that we've got? So that's just an opinion piece. I just want you to think about it. But um, I highlight this one because uh, with any model you use, there may be different constituent groups. So it isn't that everybody has the same objectives. And I know in public policy decisions, we always have, um, if it's environmental, it's industry on one side, environmental groups on the other, and they argue back and forth because they're both looking at it, having different priorities between the two groups. And that's very, very common in all kinds of decision-making situations. Anyway, so that wraps up your assignment. Are there any questions about the assignment? Things that now are not at least reasonably clear, if not cleared up completely? Nobody's typing? You're good then? Okay, I expect 10 out of 10 on these, and you're good. Okay, so if you're good, then I'm going to go and uh, do a really quick slideshow, if you don't mind. I just want to finish up the term. I've got unassign and present. Good. Okay. And this is all being recorded. I had problems turned out yesterday. I can't guarantee the recording worked. Yesterday afternoon, something didn't work. I didn't get the recording back. But the one from 11:30 yesterday is posted, and after class I'll post this one. So my ending pictures are the ones from the first session. My able assistant Dora, who was with me at the start of class, but she seems to have left me now. And the two sleepy ones that haven't been around much. If I remember correctly, Sam made a brief appearance at the end of last class. Um, but Bruce is kept in hiding the whole time. Anyway, just coming back full circle in a sense, I've tried to present the material in a sequential fashion that this is all a package. It isn't just a collection of little tools. And so often in our math courses, quants courses, we just go and here's enough. You saw it in Quant 1 if you took our Quant 1. If you've done a stats course, you've seen it. It's a whole bunch of tools. It doesn't tell you about solving problems. Doesn't tell you how to build a house, even though you know how to use all those tools. So we've gone from trying to define the problem and understanding the business, understand the data, doing some analysis, some modeling in it. We've quickly zipped through evaluating the model results, that type of thing, trying to interpret it. And now we've got to sell it. That's what deployment is. It's selling. It's convincing people to follow your suggestions, to believe what you found out. And it is a sales job. It doesn't mean being dishonest, but you have to be persuasive. That so you've got to think through in execution of this. Okay, this is not the planning stuff. You're now going to act upon it. Thinking about, did you really solve the problem that you was posed at the beginning, or did you get off track and got a really nice answer, but not to the right question? Do you think management's going to believe you? Do you think they're going to use it? Does this resonate with them? Do they understand your performance measures? If you're going to give them sensitivity rates and they aren't going to like those words, but do your metrics, are they the ones that fit with them? Or with this last one, if you were speaking both with the company and the union, the truckers union, are you able to convince both that you're both achieving your objectives? What risks are there? That Generally, with a big project, we talk about deliverables at the end. Now, the deliverable might be a building. It might be implementation of some software. It might be a reorganization plan for the firm. It may be a marketing plan for a new product you're introducing. And there's generally a summary report, which some people may read, but a lot of lazy people won't. And or they're busy people may not read it. Recommendations. Those are your key points you're trying to hammer home. And that those are the easy parts. The hard parts are things like an implementation plan. How are you going to actually implement it? What steps need to be done next? Uh, and even if you get it implemented, are they going to be able to maintain it? Because if this is a prediction model, you're going to get new data. You know, well, you should put the new data into your model and update your model and maybe throw old data out because it's no longer relevant because it's old. But you're going to do update. Who's going to do that? Can they do it? Do they have the expertise to do it? Um, that I can think of uh, one big project that had to do with building a mini website to inform students about certain things. It ended up being a disaster because people didn't use it. uh, but even those that did, it would have to be updated every year, and they never thought about that. And nobody wants to do the update. So it went stale quickly. It's out of date. Um, and people won't use it because they hadn't thought of a maintenance plan that um, and they definitely didn't do a lessons learned report. They didn't learn any lessons. I'd expect that group to, or some of the lead people, to make the same mistakes all over again. Um, an implementation plan, and with this one, even they built the website, but to get people to use it, that was part of implementation. And they didn't think about, well, how? Who's going to use it? How are they going to do it? What needs to be involved? How are we going to monitor whether or not they're using it? And are we actually getting the benefits out of it that we thought we would? Yeah. Um, that implementation is often where projects fall apart. That we built everything, but we didn't implement it properly, um, and it's not functioning well. I can think of that of change management, of doing a reorganization. The implementation, more often than not, has been a disaster. Oh, there's Dora. She's chewing up a rubber chicken. Okay. A lessons learned report, it's going through the various stages. And so in a data mining one, it's problem definition. Where did we run into the gap between the business problem and the data analytics problem? You know, so that did we get good alignment? Could we have done it with less work? Data selection and collection. Did we really get the right data? Probably not. It's hard to do it the first time. But if we're doing it again, and if we're going to collect more data and do updating and maintenance, are there things that we could do better in the future? Um, Modeling, is there a different approach you may want to consider next time than what we did this time? Client relations, that's always a big one. With projects, if you're a consultant doing a project for someone, client relations is the worst part. It's really hard. Um, anyway, uh, it's complicated. So we've been using this framework called CRISP. This was a slide I used last year with my class because they had to do a project. And so many of them wanted to write the report, their summary report, all about CRISP. I said, no, they don't care. They don't care what strategy you use for going through this. They just want to know what did you do? What did you find? Um, so figure out what's the story that you're trying to tell in the report and then tell that story. Don't get bogged down with technicalities and things. This is storytelling. Storytelling has a beginning, middle, and end. Group projects. You're doing a project, presenting it. I know I can't remember which class it is the fellow was in. He couldn't attend class because he had to present his group project in a different course. I hope in doing the project they didn't say, oh, I'll write the introduction, I'll write the conclusions and implementation plan, and I'll write the middle stuff. And then they bring it together and they cut and paste and put it all together and submit it. Doesn't work. I know from reading them, the middle stuff doesn't seem to speak to the stuff at the beginning. The thing that they said they were studying and why doesn't seem to fit with the analysis they're doing. And the conclusions, I don't see how you drew those conclusions from that analysis. Even though they discuss things, because it's written separately, the parts don't stick together really well. If you got a group of four, then have team member number four have the job of taking all of this and doing an edit and a rewrite so that it runs smoothly beginning through to end. It's got to build on itself. That so feeding it all the way through. And the parts you emphasize are the exciting parts. Try to make the boring parts short if you can. Put them in appendices, that type of thing, because they're not going to read them. They're You want them to go and read from beginning to end. So the stuff you think they're not going to read, so they know what to skip over, you put that in an appendix or something. There are creative ways of doing it sometimes. That the conclusions they should have guessed at before they finished it. So this isn't a mystery novel where, oh, the butler did it. I wouldn't have thought that. Big surprise. No, no surprises in the report. Maybe in the analysis, you're surprising them, but not with your conclusions because you're leading them to believe the conclusions at the end so that they're already guessing what your conclusions are because the analysis is leading you only to that destination. That um, they you're focusing on actions they should be taking. That may mean you've got to go back and investigate something further because we don't think you should take actions yet. Investigate it more, and that you've got to be careful about this, and it depends upon the organization. Some of it you may not be able to recommend how to do it because of aspects of the organization you don't know who does what, that type of thing. That um, write it in a format that would make you want to read it. Think about what do you read and what don't you read. When you took economics, did you read the textbook? I've yet to meet a student who's read an economics intro economics text beginning to end. Um, they most students say they scan it. They depend upon their lectures, whatever. And it doesn't matter what the textbook is. There's so many words that they get overwhelmed. Um, Even if you were reading stuff online, if you're reading stuff on a web page or whatever, you scan it. Um, oh, sorry, Tristan, my mistake. Um, that it it's really hard to read. Um, we scan stuff, and when you scan stuff, it's a visual thing. So where's your eye drawn? It's drawn to headings, it's drawn to pictures, graphs, charts, maybe to tables, things that. But the heavy paragraphs there, it's just blur. We skip over it. I do. Everybody does. Managers do. They're not any different than anybody else. They've got a lot of things to do, a limited amount of time, and so they read the beginning and the end. And if they read the middle, they're scanning it. So think about that when you're putting it together. And that's why I draw attention to charts. Charts people do look at more so than text. So um, that the chart almost tells the story, and the text that you have may give further explanation of the chart that's above. But the chart, if it's well designed, often can speak for itself, and they don't need to read the text at all. Make sure your data is clean. Um, that if there's strange things in the data and they show up in that chart, it's going to draw their attention. It's like your eye being drawn to outliers. And just don't worry about the outliers. Worry about the main stuff. That not about that 1 in 1,000 that's different. What about the other 999? And so be careful about that. They, um, if you've cleaned your data, you should be honest and say you cleaned it, but put that in a footnote and to say what you did, or talk about it in an appendix about how we cleaned the data, because they don't want to read that, but it detracts from the report. So John Tukey, the guy that gave us um, uh, the box and whisker diagrams, he had a quote that saying that a picture is a great picture is one that forces us to see what we never expected to see. Okay? It tells us a story, and this is storytelling, like telling a children's story, which I'll end with talking about that. So we had a bunch of standard charts. We've used several of them, and there's several that we've not, but I'm going to run through these. And there are also some special purpose ones, and I would be hesitant to use them unless they were designed to fit your story. Um, so line charts we haven't used because we haven't looked at time series data. Probably should in this course on hindsight. That's one of the areas I want to look at in the future. There's a lot of data, especially economic data, is time series. A lot of sales data, and we're looking at changes over time. This is real data. It's from a report from a couple of years ago, looking at the changing demographics of business students at Nova Scotia universities. And it was to explain that uh, Nova Scotia students studying at St. Mary's and Dal and X and so on has been in decline. The reason is not that they don't want to study business, it's that we have fewer graduating high school students, or we did over 20 years. We saw a decline every year. And so that was a demographic decline. That in about a little more than 10 years ago, international enrollments took off, shot straight up. That was a lot of it being China, but a number of other countries as well. And then it actually went into decline. I don't know where it is now. I think if I added one more year, CBU gave us an uptake because they did a very good job in recruiting in India. Um, that but we lost a whole bunch of Saudi students because of a fight with the Saudi government, as well as others. And so it's been going up, but this one went down. And this is Ontario. You may not have realized how big Ontario is as a market, much more so than the rest of Atlantic Canada or Western Canada. And this is mainly at Dalhousie. Dal has done a very good job recruiting in Ontario. Um, that was talking about the individual segments and how they change. But if you're interested in total enrollments, then a stacked line graph works better. So this aggregates those like layers of soil or something. And it's so I've got this big hill here, and now I'm on the decline still. The international is driving that, as well as Nova Scotia ones in this last bit. That this here's Nova Scotia down here. I put international up there and these others in the middle. It's hard to see clearly. Ontario has grown over time, but it's not so clear. And this one's a fairly stable graph. Ones that where there's a lot of waviness to it are harder to read. It's hard to say how certain segments change over time. How Atlantic Canada has changed over time, it's increased. Um, that BC and the prairies has stayed about the same over time. But you're looking at the width and seeing how they move. And that's harder for us to interpret. But this shows me the aggregate. It emphasizes how important each of certain segments are and how small other segments are. But it doesn't give me a good way of looking. If I just was interested in how international are changing over time, then I should use this graph. But if I want to look at in the aggregate, the pluses and minuses of different markets, then I should use a stacked line graph. These ones you have to be are trickier to work with. Both of them are very hard to do when I've got 5 different segments I'm looking at. If you were to draw 7 different or 10 different segments, I've done this one with all of the Atlantic universities, and see how do they change in terms of total enrollments in a simple line. Too many lines. It's hard to interpret. So eh, there's an art to drawing these carefully, but they can be very informative, great for time series data. Pie chart's another one we haven't done, and I hope you never use. And I'll try to explain why. So it shows, so suppose this is a company, it's looking at sales in the Netherlands. It sells four main product groups, A, B, C, D, and of their total sales, here's how they split. So um, A makes up 22%, B makes up another 35, C 11%, and D 32%. What's the story here? What am I trying to tell? I don't know. If I'm trying to look at the relative sizes of these different ones, it's tricky to interpret um, because you're comparing areas of strange shapes, and that's very difficult to process. It's not just saying that this guy is higher than this one. They're just simple vertical distance. Area is very tricky to compare two areas and say one area is twice as big as another. That's hard to actually spot because area has two dimensions. That this is tricky to work with. A lot of people like three-dimensional ones, and Excel can do that for you. This is all done in Excel. And to give 3D, usually you have to tip it to give you depth. Well, in tipping it, you'll notice this is not a circle anymore. It's an oval. So it stretched anything that goes left to right, and it shrunk things that are going top to bottom. It distorts the sizes. The, the relative sizes of these pies are now different than what they were before. And but it's a nice picture, but it's junk because it's not. What's the information? What's the story it's trying to tell? And this is um, if you need a picture in a document because you've got so much text and people are bored reading the text, and you want to give the eyes some relief, a picture is good. And that's why they're used in magazines and on websites. We use them for visual relief. And this might do that, but don't use it to convey information. If you were trying to compare the four markets this company operates in by how different products sell and different how important they are, I guess that's what it is. A is not very important in Belgium, but it's very important in Austria. That C is not very important in the Netherlands, and it's not that important elsewhere, but it is somewhat more important than it is in the Netherlands. You can go and do that, but what is the story? Have you thought about what you're trying to achieve first before you select the chart type? I was involved in designing and building the Sobe building at St. Mary's. And through the 2 years I worked on the project, I worked with a project manager who was a former architect. Our job was to define our objectives. What was the building supposed to achieve? And at each stage along the way, in watching what the architects did and what the builders were doing, to make sure that they were meeting our objectives. And Bert kept saying to me over and over again, form follows function, and good architects know this. First, you define your objectives, then you design something to meet them. Don't design a pretty building and then try to make it do what you want to do. That the building design starts with the objectives. So your choice of chart starts with your story and the objectives behind the story. Don't start picking a chart because, oh, I want to show percentages. Pie charts are good. No, think about why you want to show percentages, why you want to show stuff. If if I wanted to just say show total sales, I could use a clustered column chart. So this is just total sales. I sorted it with Netherlands as my smallest market, Norway is my biggest one, and I put them in that order, and with the products A, B, C, D. But some of the products, in particular C that we've noted before, is the least important product overall. In most of the markets, it's the least important. On the other hand, product D product B, the orange guy here, in most markets, it's the most important or almost the most important. So why don't I sequence my products? Nothing magical about their names. as CADB, and maybe then I look across to see how it's changing. So um, that may be a more informative way of presenting it if I want to show total sales. Pie charts don't show total sales, they show percentages. So let's go back. If you wanted to look at that mix of the importance, I could do it with totals and use a stacked column chart, like a stacked line chart, and show Netherlands is much lower than Norway. Norway is much bigger in total sales. And I can look at the blocks and see what's important. And I can see that, the different sizes of these different ones. But again, it gets tricky. This orange here is a lot bigger than that orange there, but that's because Norway sales are a lot bigger. Maybe as a percentage of the total, it's not much different. It's just that this is a big total, so each of the chunks are bigger. So I could do it as percentages. And so here I've got up to 100%, and that I can split it that way. This is more like a comparing four pie charts. It's still tricky. I find it easier because I'm still looking at vertical distance, and I'm looking, if you wanted, at areas, but they're simple areas. They all have the same width. So I find these easier to compare than a series of four blue slices or a series of four orange slices. They're tricky to do. Okay? That I can do this stuff again. That's as a percentage. If that's what I wanted, I could do it as um, as a clustered column chart. Maybe that will help me. There, it's simple to compare the oranges. So uh, they may be somewhat similar across there, and which ones are quite different across one to the other. What are you trying to show? There's so many different choices you've got, and you've got to be clear on what it is, what you're trying to tell someone before you go and build this chart. I showed you a whole bunch of variations on the same thing. One other variation is if you've got a number of groups and the labels are quite long for the groups. People have trouble reading vertically, and it's easier to read horizontally. So if you've got this, turn your chart sideways and do it as a bar chart. And again, I recommend you sequence things. So here I did smallest to largest, here I did largest to smallest. Make it um, visually appealing. People see patterns that are there. They want to know who's the biggest seller, who's the smallest seller. Are there a lot of small sellers? Are there a lot of big ones? So you're conveying other information. This one I'm conveying, how is it changing over time? Doesn't seem to be changing an awful lot. Here I made a mistake. Notice I start with 2017 and I end with 2014. Bad mistake. People's gonna notice that, and it's gonna affect my credibility. Okay? Be careful. Check these things. It's really easy to miss little stuff. We've done this, so I'm going to skip it over. If you're comparing distributions, I like the box and whisker. The histogram is just too busy for me. It's tricky for me to study. Scatter diagrams, just want to point out this is an extreme of not paying attention to detail, and I'll show you one that is, and it changes the way it presents it. This is from a student project last year, and actually several groups used the same data. They had choice in the projects they did, and they made the same mistake. They were trying to show the relationship between high school average and first year grade point average, and did a scatter chart to show the pattern or the lack of a pattern. And uh, there's a group of outliers. There's some down here. There's one over here. Those should have been cleaned up. They don't belong here. There's something wrong. This is a student with a grade point average of 15. An A plus is 4.3. How do you get a 15? Um, Here are three students that reported a high school average of 0. No, they didn't have a high school average of 0. Again, a data error. It should be a blank. So take those out. My axes, I don't even know what's on the two axes, and they're backwards. this is high school average. This is grade point average. I should have it the other way around. So here's my revised version. And so it's cleaned up those things. And then I gave it a title that I don't even need the picture to tell me. The picture reinforces the title. High school average isn't a good predictor of university success. So um, that uh, the title is an opportunity to really hammer home a point and make use of that. But then the picture reinforces the story. So if that was the message I wanted to take, this picture reinforces it. Um, I'm not going to spend time on this, but if you go, you can Google this. This is Daily Stats. It's produced by the Nova Scotia Department of Finance every day that it's put out. Um, it's the director of the Economics and Statistics branch of Department of Finance. He also teaches economics here part time. Um, what's his name now? Thomas Story? I can't remember now. But they follow a standard format. If they're showing stuff over time, they'll often start with a line graph. This is a time series. This is the light line is the um, actual, and then because there's so much variation, they've put an average, a smooth line through to emphasize the pattern. This is building permits. That this is for residential construction and for non-residential because they felt those were two groups. They should be separated in the graph. So it's only comparing two groups over time. And then Halifax is very different from outside of Halifax. So they had graphs for each of those. Nice, simple ones. They had some text, but the graphs told the story quite well. They went on to show with the building permits in the residential, non-residential, how it's changing for Halifax, for Nova Scotia, for Halifax, and outside of Halifax. And they decided to do that with bar charts. And they did it as a percentage change and as a dollar figure. They did both. Um, they looked at it by region over the last 2 years, and then by region in a different fashion over the past 10 years. And they did it there using a stack column chart. And so you're seeing in total how it's changed over time and where the Halifax is driving everything and what it's a boom year or not a boom year in Halifax is what drives everything in it. Again, the story comes out quite quickly through it. They've got others in terms of national figures, and there they like to use for percentage change. They like to have relative to a zero line and bars up, bars down. They use the same format every time with their reports so that they can give a huge amount of data that you can read in 5 minutes with large number of charts and a small amount of text. They do an excellent job on all kinds of different issues. Every day something new. Um, this is a chart that initially I thought was a badly designed chart, and that's what I wanted to use it for. Because we talk of the uh, ink to data ratio, or how much information is there and how much ink do you have in the picture. And don't have too much ink. Keep it as simple as possible. And this one was from Statistics Canada. It came out last year, and it was showing the number of female faculty members that back in the early 1970s, when I was a student, um, there were very few female professors, less than 15%. And now it's up around 40% or so. And it's been steadily going up. In terms of deans, senior people, unless you're a dean of a nursing school or something, very few females. Now it's fairly common. It's been going up. A little bumpier because we're talking about in smaller group of people. So why do they have to give the data for males? If I've got here around 1990, it was about 20% female faculty, and so it's 80% male. It's one or the other. I don't need this if I got this thing. Why did they put it in there? This one, it was a disappointment. This was Statistics Canada, and they tend to use very boring titles on charts. They use better headings on text, but on charts it's very boring. I would have said the gap between males and females is decreasing, or it's decreased over the last 40 years. Because here's the gap, and it's smaller and smaller and smaller. It's starting to slow down in terms of closing the gap, but during from uh, 1990 to 2000, there was a fairly rapid change in terms of changing the composition. So if the story was the gap is decreasing, show a picture of the gap decreasing. That, um, they didn't need all of this detail, but it can be a very strong image, strong picture. Um, this is one I used when I used to do recruiting. That when I started doing it, we did most of our recruiting really after Christmas and get our applications in February and March. And so, well, that's a missed opportunity. Why don't you try to hook students by applying in October, and then you can work with them since October to complete the sale and be the first one to make them an offer, that type of thing. And it usually is a good marketing ploy. Um, Other schools end up following, doing exactly the same. But we all started recruiting aggressively in the fall, the same students that would have applied in the winter. So it made our fall application numbers continue to go up. So at the end of December, we went from only 500 applications, we were up over 1,000, and last year's doing it was around 1,500. And the budget committee was just thrilled because in January they started building the budget and they were using this as their financial forecast. I say, no, it doesn't work that way. But look at the numbers. You're giving me the numbers, and our applications are up 20%. Um, where are we going to put all the students in September? So I had to show them a graph to say that, yes, in the old days, went up and then it just kept going up. And we ended up with almost 4,000 applications by September. But look at what happened last year. That's the black line. It was way ahead of where we were before, but then the lines cross. We ended up below 3,000 applications. They just applied early. We've changed their behavior. Um, they started to get it, but they still kept getting excited. We're up 20%. They went ahead and budgeted for an increase that we didn't get. Anyway, it's you've got to find certain creative ways of trying to tell the story. I did a bunch of these, and I'm not going to get into them, of ways of doing that sort of thing. Um, but sometimes you have to manipulate and make custom graphs because there is this story. And again, it's this form follows function. What's your objective? Craft a story around that to help you convey that. And then put in illustrations that really emphasize the points you want to make. And it's like storytelling to children. And if you've read bedtime stories to small children, the child looks at the pictures and you read out the words. And the child is really interested in the picture and they're learning the story through the pictures and they may be listening to the words. That's the way your report is. They may be reading it, but they're really paying attention to the pictures. And so if you haven't done a compelling job with the pictures, you're not going to get it with the rest of the story. Um, and that small children in particular, it's the pictures that get them excited about the story. Um, and but it's also the language that's used in the story. Um, and then I can think of some books where it was just the language that was used and it got my daughters excited, and others they just sort of, oh, it's dull. You've got to keep them engaged or you're going to lose them because they're not going to read everything you give them. And that is the end of the story. Um, our course is over. I've run way over time. I don't know if you're still here. We're not having a class next week. This is our last class. So this is the last time you see me. Uh, Hopefully one of these days, uh, you'll be allowed on campus to take classes and I won't be afraid to set foot on campus and catching COVID and we may meet. I would encourage you to drop by and visit me. Uh, so you guys, good luck with your other courses. Hopefully you'll do fine with the assignment for tomorrow. And in the end, we're going to get a decent grade in this course. So you guys take care, and I will be following up with a survey that I really hope you would complete to tell me what I'm doing that is a good thing to keep doing, and what are things that you've seen in other courses that you would recommend that I try doing um, in the wintertime, and to make this a stronger course. You have a good Christmas break, and uh, uh, thank you very much. Bye bye.